In this week's lab, you'll be performing various types of reactions and measuring solubility. So solubility has to do with the ability of ions and its counter ions, cations and anions, to remain dissolved in water. Sometimes they don't dissolve in water and they crash out. By crashing out, I mean they precipitate. So just as a previous lab that you've done before, you're going to react each of these bottles with each other. All of these are aqueous solutions. So as before, we will take about 1 ml of water to determine our 1 ml mark. So that's about 1 ml. Set your 1 ml mark. So I like to use a Sharpie, so that's 1 ml. Let's do another 1 ml. So the first one is 1 ml. The second line represents 2 mLs. So what we'll do now is we'll just dump this into the sink. I have my 1 ml mark. I have my second 1 ml mark. So I have all the reagents that I'm going to be mixing. So we'll start off with the first one here, magnesium nitrate and sodium hydroxide. And the same thing that you've done actually in experiment 5. In experiment 5, you were looking at aqueous solutions. And here we're looking at solubility of precipitates. Okay. So here we have sodium hydroxide. Okay, always take a look at the concentration in molarity. So this is 1 molar sodium hydroxide, so I'll fill that to the 1 ml line. It's about 1 ml. And according to the table in page 4 of your lab, you're going to react that with 1 ml of magnesium nitrate. Note the concentration here. Okay, so it's 0.2 molar magnesium nitrate. So here's my 1 ml of sodium hydroxide, 1 ml of 1 molar. I'll react that with 1 ml of 0.2 molar magnesium nitrate and get it to the second line. See what you see in terms of your precipitate. If it's turbid, if it's cloudy, if it's jelly, if the solution has any type of characteristics visually. In this case, you want to be as descriptive as possible in describing your precipitate, whether it's there or not, whether some of it is there, whether some of it has dissolved. So here in this particular lab, description, qualitative observations that you note down in your data table and your notebook are going to be very important. So you will complete this table reacting these reagents in the lab. Remember 1 ml to 1 ml. Note down the concentrations of these chemicals that you're reacting with, as well as the volumes in your laboratory notebook. And when you complete this table, you want to observe what you see in terms of the precipitate. So let's just take a look at this. Magnesium nitrate reacts with sodium hydroxide. Magnesium nitrate is soluble. It's completely dissolved in water. So really, aqueous magnesium nitrate is magnesium ion plus nitrate ion. Sodium hydroxide, aqueous in solution, it's completely dissolved in water. So sodium hydroxide, aqueous, is nothing more than sodium ion plus hydroxide ion. All of these ions are aqueous. So you'll do your reactions where the cation will react with the anion. Anion is negative in charge. Cation is positive in charge. And you will get magnesium will react with the OH minus. And sodium will react with the nitrate to give you sodium nitrate. So look at your solubility table. One thing that's almost universal in the solubility chart is all nitrates are soluble. You might as well just memorize that. But what about the solubility of magnesium hydroxide? Okay. What about the solubility of magnesium chloride? What about the solubility of magnesium iodide? What about the solubility of magnesium sulfate? What about the solubility of magnesium carbonate? What about the solubility of magnesium oxalate? Write down your observations. Make sure you look and see what the precipitate is, the quantity, the amount, how it looks. Again, we want to hit really hard on the observational features of this lab. Same thing here, the calcium hydroxides, the calcium chlorides, the calcium iodides, the calcium sulfates, the calcium carbonates, and the calcium oxalates, the strontium oxides, the strontium chlorides, the strontium iodides, the strontium sulfates, the strontium carbonates, and the strontium oxalates, the barium hydroxide, the barium chloride, the barium iodide, barium sulfate, barium carbonate, barium oxalates, and finally, the lead hydroxide, the lead chlorides, the lead iodide, the lead sulfate, the lead carbonate, and the lead oxalate. What do their precipitates look like? Are they soluble, or are they not very soluble and they crash out and they precipitate more? Also note where these ions are located and situated in the periodic table. Where is magnesium in the periodic table relative to calcium? Where are those ions located relative to strontium, relative to barium, relative to lead? Look at the positions of these ions in the periodic table, as well as looking at the solubilities of the corresponding hydroxides, chlorides, iodides, sulfates, carbonates, and oxalates for these ions: magnesium, calcium, strontium, barium, and lead. So that will be your lab. Once again, be very descriptive in what you see when you react these chemicals, these aqueous solutions together. Be very observant on the amount of precipitate that forms. Is it slightly soluble? Is it completely, totally a precipitate that is cloudy? Is it turbid? So write down all that you see. And I want to mention in the lab is not only practice safety, but minimize waste as well. So when you get and make these reactions, have one big waste container, maybe a 250 ml beaker, pour it in, wash with a good healthy wash of tap water and DI water, and then bring it back for your next set of reactions. Clean test tubes all the time when you do your reactions, and always minimize waste. So have a fun lab, have a safe lab, and enjoy doing these chemical reactions.